Akoba to the math classroom. Highlighting today, we are looking at exact differential equation. In our previous lesson, we said you could solve your differential equation by checking if the differential equation is what? Separable. And if it's not separable, you can try the homogeneous coefficients. Another way you could solve your differential equation is to check whether your differential equation is what? Exact. So given a function, let's have a function f of x, y, I can write its total differential. So let's say the total differential, that is df of this differential equation, is going to be defined as, so I have df, the partial derivative of f with respect to x dx, plus the partial derivative of f with respect to y to be equal to dy. Okay, so this is the total differential of what? A function. If I want to find the general solution, so let's say the general solution of what? F of x, y, x what? C, satisfying the condition that my d of f is equal to 0, then I could write d of f to be equal to partial derivative of f with respect to x dx, plus partial derivative of f with respect to y dy to be equal to what? 0. What do you realize here? You realize from an initial definition of a differential form which said m x y dx, this is a differential form, plus n x y dy, it's equal to what? 0. So if I compare to the differential form, you realize that this is equal to that, and this is also what? Equal to what? This. So I have m x y to be equal to the partial derivative of f with respect to what? X, and the partial derivative of what? Y. So I have n x y to be equal to what? Partial derivative of f with respect to what? Y. Okay, very good. So if this is true, then we are saying that this is what? An exact what? Form. This is what? An exact differential what? Form. And if it is so, then I can check if it is what? Exact. So to check if it is exact, then what we have is, so to check if it is exact, our differential equation is exact, then we have, if the partial derivative of f with respect to x, it's equal to the partial derivative of f with respect to what? Y. That is, if I differentiate f and they are equal, if I differentiate the partial derivative of m with respect to x, and I differentiate m with respect to y, let's say m with respect to y, and I differentiate n with respect to what? X, and they are equal, then I can say my differential equation is what? Exact. So let's look at this. If I have this differential equation, so let's say I have this differential equation, I have 1 minus 2xy dx plus 4y cubed minus x squared dy to be equal to 0. What do you see? You realize that this is my m and this is what? N. So let's find the partial derivative of m with respect to y, which is going to be equal to, so this with respect to y, what do you have? I have minus what? 2x. Then let's look at this, the partial derivative of n with respect to what? X. Okay, so with respect to x, this goes to 0, so I have minus what? X squared. If I differentiate, what do I have? Minus what? 2 what? X. So what do you see? You realize that they are what? Equal. So they are what? Exact. So because they are exact, then I can solve for what? This differential equation. So our next lesson, we'll look at how to solve an exact differential equation. Till then, kindly stay safe. Bye.